Do you know what desalination means? It's a method used to convert seawater into potable water, which means drinking water. So here we've got seawater and groundwater are treated to make them potable. Remember, that means safe to drink. And we've got a table here which shows two different processes. So for the seawater, we've got Na plus ions and Cl minus ions. These are just floating around in the water. And there's a process called reverse osmosis, which is a process that you need to know about. And that process removes the ions from the water, most of the ions anyway. It uses a type of membrane. After that, we've got another process where they add ozone to it. Then we've got groundwater. Again, we've got some ions in it, not as much as seawater because seawater is salty, so it's got a lot of NaCl in it, sodium ions and chloride ions. So groundwater doesn't really have that much in it. That's why the levels are much lower. Here we use filtration. We don't use reverse osmosis, probably because the levels of salt are very low. And then after that, we expose it to ultraviolet light. So the first part says which pair of concentrations could represent X in the table above. So X is here. It represents the Na plus and Cl minus ions after the reverse osmosis has occurred. So remember, reverse osmosis removes the ions from the water. So ideally you would want 0 of Na plus and 0 of Cl minus by the end of it. That's what you'd ideally want in X. But we don't have that option here. It's not going to be 0.5. It's not going to be anything with 0.5 because 0.5 was the starting value. The value needs to decrease because we're removing the Na plus and the Cl minus from it. So it has to be something which is lower. So it's not going to be this one because we've got 0.5, we've got 0.5 here, and we've got 0.5 here. The answer must be the top one, which is 0.003, which is very small. We can almost say it's negligible. Second part says, explain why the concentrations of sodium ions and chloride ions in the groundwater in the table above are unchanged by process 1. Process 1 is filtration. Filtration doesn't remove ions. Like if you think about getting salt water and putting it through filter paper, it doesn't remove the salt. To remove salt from salt water, you need to use evaporation. So that's because the ions are so small that they can pass through the holes in the filter paper. Same thing with filtration here. So the ions pass through the filter because they are smaller than the holes in it or the pores in it. Next part, explain why the groundwater in the table requires process 2 before the water is safe to drink. So groundwater needs exposure to ultraviolet light. The reason for that is because it contains a lot of microbes, a lot of microorganisms that can make people feel ill if they drink it. You need to basically kill those before it's safe to drink. So the ultraviolet light can kill the microbes. So we can say the water contains microbes which are harmful to humans. UV light kills the microbes. Next, part E, after the treatment of groundwater in the table above is sold by a company as pure water. So just what the company means by pure, they basically mean nothing's added to the water. They've just purified it and then that's it. They're just selling it like that. So we can say nothing is added to the water.